All right, so this is lesson 2 of chapter 1, measuring and constructing segments. And I want you guys to think about why we aren't measuring lines. Well, lines extend infinitely in both directions, so it's impossible to find their actual length. So for this purpose, we're just focusing on segments. So our essential question is, how can we measure these line segments? Well, this first example is simply by using a ruler. And if you notice, I don't even start segment ST right at the beginning of the ruler. I set it on a nice even increment, and then I just count approximately 3.5 centimeters. So that's one way we're able to do it. And then this means approximately when it's just that squiggly equal sign. The next way we can do it is finding the length on a number line, and you'll see it's always going to have a starting point and an ending point. So our starting point's at -6 and our ending point's at 7. So we can just subtract the difference. We can take the starting point minus the ending point, or we can take the ending point minus the starting point. But distance is always positive, so we have to take the absolute value. So if I evaluate this, -6 minus 7 is -13. If I evaluate this guy, 7 minus -6 is a positive 13. I accidentally wrote a negative in front of there. So you'll see, once we take the absolute value of -13 is positive 13. Likewise for the absolute value of 13. So the distance will always be positive. Just make sure you're taking the absolute value to account for if you have points that are on the negative area. So the next thing we're going to talk about are congruent segments. Segments are congruent if their lengths are equal. And we never say segments are equal. Segments are congruent because their lengths are equal. So there's just a difference. Lengths are equal, segments are congruent when we're using our vocabulary and when we're talking about it. So if I plot the points on this coordinate plane, point A and B. B's at 4, 3. And then I connect those. And then I plot point C is at -4, -4. And D is at -4, 1. And I connect those as well. I'm going to determine if the segments are congruent. So we just learned if they have the same length, then they are congruent. So when I do just count on that coordinate plane, AB has a length of 3. And CD has a length of 5. I want you to notice something because we just learned how to name segments. When I'm talking about their length, I don't put that segment bar above A, B, and CD because I'm talking about their length. If I'm talking about the segment itself, then I will do it, and you'll see it here in a second. So since their lengths are not equal, segment AB is not congruent to segment CD. All right, let's try it one more time and just see what happens with this guy. So A is at -5, 5. And B is at -2, 5. And that looks like it has a length of 3 again. And then C is at 2, -4. And D is at -1, -4. And it looks like this segment also has a length of 3. So the length of AB is 3. And the length of CD is 3. So since they have the same length, segment AB is congruent to segment CD. And then that symbol right in the middle, that's our sign for congruency. It's an equal sign with a squiggly line above it. That means congruent. And again, geometry is all about making conclusions. So I had to know that the lengths were equal in order to say that the segments were congruent. So it's, again, we're making a justification based on information that we can use to prove it. Now we're going to be using the segment addition postulate to find length. So what the segment addition postulate is it takes little pieces of a segment and it adds them together and it sets them equal to the length of the longer segment. So in this image here, you see I actually have 3 little segments, segment AB, segment BC, and then together it creates segment AC. So we're going to be adding these little parts together to create a whole segment, or longer segment. When we do solve all these problems, you'll see here in a second when I go over the examples that I want you to write out the equation. This is essential. It may seem kind of silly right now because when I'm asking you to find the length of DF, you might think, oh, just add this guy plus this together. But we're going to involve more algebraic equations. So I want you to write out the equation using the segment addition postulate. So what that looks like is the length of DE plus the length of EF is equal to the length of DF. So you're just writing that out with no numbers or anything. You're just using the letters. You're just using the segments. And then what I can do is I can plug in, or I can replace, DE is really 23, EF, the length of EF is 35, and I don't know what DF is, so I'm just going to leave it. And then I can combine like terms. 23 plus 35 is 58. And that gives me the length of DF. So again, it might seem silly, but this part is crucial for later. Okay, so again, we're trying to find the length of GH this time. So it might seem like, maybe comment, I don't know, it might be stick out to you right away that, oh, I can just take the length of the whole thing and subtract the length of this little part here to get what's left. But I still want you writing out the equation using just the points. So the length of FG plus the length of GH is equal to the length of FH. And now I'm going to replace. Now, since I don't know what the length of GH is, I'm just going to call it X in this case. So now it kind of looks like a one-step algebraic equation. And then to solve for X, I can just subtract 21 from both sides. And I'm left with X equals 15. That must mean then the length of GH equals 15. So don't leave it as X. Actually write it out, GH equals 15, the length of GH. So here's where it gets a little tricky, and this is why writing out the equation is essential. Because now I have these variables, I have these expressions, and it's a little bit harder to just picture what you need to do. So I always want you writing out the equation. So DE plus EF equals DF. Now I'm going to replace, or plug in, substitute. Actually, that's the correct term. I'm substituting 5x minus 2 for DE. I'm substituting 3 for EF. And I'm substituting 3 times the quantity x plus 3 for DF. Now I'm just going to combine like terms on the left-hand side, kind of clean it up. So I'm left with 5x plus 1. And then I am going to distribute on the right-hand side while I'm at it. So 3 times x is 3x, and 3 times 3 is 9. And I prefer to get my x's on the left-hand side, so now I'm going to solve for x by moving the 3x over. So I'm left with 2x plus 1 equals 9. And then I'm just going to continue solving this multi-step equation. And then I divide to get x equals 4. So do not stop here. Yes, you got x, but let's go back to the original question. It says find the length of DE. This is not the length of DE. 4 is not that. That's the value of x. So we actually have to take it one step further. I know DE was represented by that expression 5x minus 2. So I have to take that and replace or substitute in the value of x that I got. So don't get the question wrong by writing 4. You need to plug it in, and now I can evaluate that expression. So DE equals 18, the length of DE. All right, now here we actually am giving you some information, and you have to label the diagram and then find the length of BC. So the first step is understanding what some of these symbols mean. So let me erase that little. So this guy right here, this is the sign for congruency. I mentioned it earlier. It has an equal sign with a squiggly line above it. So that means congruent. So anytime you see that symbol, If it says two segments are congruent, then you know their lengths are equal. So this first part says segment AB is congruent to segment CD. So I'm going to label that in the diagram. And the way you label that is just by two little dashes on those two segments. That reminds me that those segments have the same length because they're congruent. And then it tells me CD, the length of CD is 10. So then I also know AB is 10 because they're congruent. So therefore they have the same length. So I'm also going to label AB as 10. Then I read BC equals 4x. So I'm going to label BC. And then the length of the whole thing, AD, is 40. So this is how I take clues and I label my diagram. Now I'm going to go ahead and use the segment addition postulate to write out an expression or an equation. So AB plus BC plus CD is all equal to AD. So this one, there was 3 parts equal to a bigger part. Now I'm going to substitute each of the lengths in for what they are. And the rest is just algebra, guys. The geometry part's over. So the geometry part is understanding the segment addition postulate. And then once you plug everything in, the rest is all algebra. So it's usually like first part's geometry, second part's algebra. That's how it's going to work a lot this year. So I'm getting x to be 5. And then remember, I'm not done. I was asked to find the length of BC. And BC is represented by the expression 4x. So I'm taking that and I'm plugging it back in. And we're done. And then we just have one more problem, and then we're finished with this lesson. So this is where you would have to draw a picture all on your own. I give you the clue that point B is between A and C on segment AC. But then I give you information about the length. So the first step is I'm going to draw the big segment. And I know B is somewhere in there between. And then A and C. And then I'm going to start filling in what I know. AB is 13 plus 2x. BC is 12. And the length of the whole thing is x plus 32. So it's just a little more work because you guys have to come up with the picture on your own. And then I'm going to keep repeating my process using the segment addition postulate. AB plus BC equals AC. And then I'm going to substitute in those values. So I'm replacing AB with 13 plus 2x. I'm replacing BC with 12. And I'm replacing AC with x plus 32. I am going to go on the other screen here just to have a little more room to solve this equation. So I'm just repeating, it was 13 plus 2x plus 12 equals x plus 32. I just want to make sure that's correct. Yeah, we're good. Okay, so guess what? Geometry part's over. We have our reasoning behind this equation using the segment addition postulate, and now I'm just combining like terms on the left-hand side, subtracting the 25 from each side and trying to isolate my variable. And then I can get x all by itself, so x should be 7. And again, I'm not done. Let's go back. It had asked me to find the lengths of all of them, of AB, BC, and AC. So now I can go but it did already tell me that BC was 12, so I'm just going to fill that in there. So I'll just have to do some quick evaluating for AB and AC. And then AB was represented by the 13 plus 2x, and AC was represented by the x plus 32. So now I can just take 7 and I can substitute in. So 2 times 7 is 14, so that should be 27. And then for AC, x plus 32 should be 7 plus 32 to give me 39. And then what you guys can do is you can check. Remember, AB plus BC was equal to AC, and 27 plus 12 is 39, so we're good.